Hi, today I will explain you the Verilog 30 days lecture series. So we completed with encoder. So today I will start with how to write the RTL code and test bench, and I will explain you to execute in EDA playground, Xilinx Vivado, and Quartus Prime and Model Sim. Okay. So first we'll see the code related to this decoder 2 to 4. The operation of decoder is just opposite of encoder, whatever we have seen in the last class. So here decoder have 2 to 4 decoder. So this decoder have two inputs and four outputs. So at a time, any one of the output will be high. Okay. So if you see the RTL code for this decoder, so this is the module, and what is my module name? Decoder 224. I need to declare input and output. Input, this is a vector 1 down to 0 in. Output, so reg, this out I am using in the procedural block. That's why I am declaring with reg data type, reg 3 down to 0 out. Always at the rate star begin. Okay, star is the implication operator. This will be applicable for all the inputs. Okay, if there any change in the inputs, then there is a change in the output. Okay, so I'm using a case statement, case in two tick binary 0 0. So this is a behavioral modeling style. I'm writing the code. So case in, if it is two tick binary 0 0, out equal to what? Four tick binary 0 0 0 1. Okay, two tick binary 0 1, out equal to four tick binary 0 0 1 0, and two tick binary 1 0. If input is 1 0, out equal to what? Four tick binary 0 1 0 0, and two tick binary 1 1, out equal to what? Four tick binary 1 0 0 0. And what is the default case for the case statement? You have a default statement, no? So the default statement is what? Out equal to four tick binary four zeros. Okay, end case and end module. Okay, so this is my RTL code. Next, you need to write the test bench. Okay, so how to write the test bench? Module, and module name is TB underscore decoder underscore 224. As test bench does not have the inputs and outputs, so we have the test bench variables. I need to declare the test bench variables that in with the reg data type, reg 1 down to 0 in, and wire 3 down to 0 out. I need to instantiate my design in the test bench. How to instantiate? Here you see. So what is my design name? Decoder 224. So decoder 224. Instance name is DUT, and this is the connection by name. Okay. So dot in, dot out, out. Okay. Whatever the variables outside the bracket are design inputs and outputs, and inside the bracket are test bench inputs and outputs. Initial begin. So for the waveforms, you need to use two instructions. Those are $dump file decoder224.vcd, $dump vars 0 comma tb underscore decoder underscore 224. Okay. So next I need to give the stimulus. Okay. So we need to try the values. I am giving in equal to two tick binary 0 0. After 10 time units, again I am giving in equal to 0 1. After 10 time units, I am giving the in equal to two tick binary 1 0, and after 10 time units, I am giving 1 1. Okay, I need to give the input, means I need to drive in the test bench to the design. Okay, drive the values to the design, and design will process and it will give the output to the test bench. Okay, dollar finish end module. Okay, so this I want to execute in EDA playground. So I'm opening one second. I'm opening the EDA playground. So here you copy this. So this is copy this, and here we need to paste, and next test bench also copy this, and here we need to paste, and go to tools and simulators. Select the tool Aldec Rivera, and use EP waveform. After run, save this file, run. So I got the waveform. So if you see here, so I can see the radix I'm giving binary only. Radix is binary. So if it is so here we can expand. So input is 0, 0. Okay. So out of 0 will be 1. At a time, any one of the output will be 1. Okay. Input is 0, 1. Out is what? Input is 0, 1. Out. So here, so this will be 1. Okay. See here. 1 will be 1. Okay. Out 1 will be 1. And here input is 1, 0. Out 3 is 1. See here. Out 2 is 1. Okay. Out of 2 is 1. And input is 1, 1. Out 1 is 1. Okay. Out 3 is 1. Okay. So when it is 0, 0, out 0 is 1. 0, 1, out 1 is 1. And 1, 0, out 2 is 1. And 1, 1, out 3 is 1. Okay. So like this, we can see the input and output relation in the waveform. Okay. So like this, we can see in the EDA playground. And coming to the waveform. So if you means if you add dollar monitor, okay, or dollar display. Dollar monitor means we can see in the log file also. Okay. So just again, I'm using Xilinx AMD Vivado, and I want to execute this code in the Vivado. Okay. So project, new project, next. So I'm giving the project name as what? Just decoder. Okay. Decoder and location, project location. Okay. So what is my project location? We are in day 7. Let us take this is a project location. Okay. Next, this is the RTL project. And here we need to give the module name only. Okay. What is my module name? Decoder 224. Okay. Copy this and here you paste. Choose the location where I want to store the project. Here in day 7. In day 7, I created decoder. No, this is my project name, decoder. Select, OK, next. This is optional only. Next, next, and finish. Yeah, my module name is created. Okay, same as module name. Here, what you need to do here. So, whatever the code is there, you need to copy and paste over here. So, this is my RTL code. Copy this, and here you paste. Okay, save, and next, coming to the test bench. So, this is my test bench module name. Copy this, go to this Vivado, go to simulation, add the simulation source, create the file, and choose the location where I want to store this. Okay, decoder, okay, finish, and module name is also same. Yeah, so go to this TB file and copy this test bench. Copy this, and here you paste. Okay, save. Now my design is instantiated in the test bench. See here, what is my design name? Decoder 224, and instance name is DOT. Okay, so after that, go to, so I want to see the design. So RTL analysis, go to open elaborated design. Okay, I want to see how the tool is converted my design into gate level netlist in terms of gates. Okay, the circuit in terms of gates I want to see. Okay. So like this, if it is a case statement, when you write for a multiplexer or any decoder circuit, you will get same as whatever the circuit is there, same like that you will get. Okay, if you are using if else statement, it will generate like a priority marks. Okay, so here I used the case statement. So two inputs are there, and depending on the input, any one of the output will be one. Okay, so this is the circuit for the decoder. Okay, and coming to the simulation, so run simulation, run behavioral simulation. So here we can open this, okay, and fit to page. You can see in the binary also. For seeing in the binary, right click, go to radix, binary, and here also right click, go to radix, binary. Okay, by default it will show in the decimal. So when see here, so that means you can expand. So when in is 0 0. So out 0 is 1. Okay. When in is 0 1, out 1 is 1. In is 1 0, out 2 is 1. In is 1 1, out 3 is 1. Okay. So at a time, any one of the output will be 1 for the decoder. Okay. So that means it will convert the binary representation of that input to whatever may be the output. Output will be high for that binary representation. So this is 0 0 means y. So like D0 will be 1 and D1 will be 1, D2 will be 1, D3 will be 1, like that. Okay. So this we have seen in the Vivado. Okay. Next, coming to the quarter sprint, here I created three files. One is RTL, and next one is sim, and next one is team. Okay. In RTL, I wrote RTL file, and in Testbench, I wrote two files. Those are the Testbench related files. Okay. So coming to the quarter sprint, so create a new wizard, new project wizard. Next, and you need to means choose the location where my project should be stored. Okay, so I'm storing in this 30 days, day 7. In this sim folder, I'm I mean storing my project, and go to this RTL 224 decoder. So give the module name only same as that project name. Okay, decoder 224. Okay, copy this, and here you paste. Okay, and next, this is the empty project only, and choose the RTL file. Okay, so day 7 RTL 224 decoder, open, and so my RTL file is added over here. See here, RTL decoder 224.v. Okay, next, select any FPGA family. Okay, here I'm selecting Max 5. Next, next, and finish. So my device, my RTL file is added. Okay. So go to analysis and synthesis, right click, start. Yeah, I got zero errors. Okay. So after getting zero errors, go to analysis and synthesis in the netlist viewer, RTL viewer, open. So like this, I'm getting this circuit. Okay. So in the EDA, it means in Vivado also like this only we got. So the tool is converted based on my RTL code into this circuit. Okay, this is a decoder. These are the inputs and outputs. Okay, so with the vectors. Okay, so that means for like this. Uh, so four outputs are there. Okay, and two inputs are there. These are the ports, input and output ports. Okay, like this, it will convert. Okay, and coming to, yeah, model sim. Okay, so go to file and new and project. Okay, I want to close this project. So what is my project name? I want to give this decoder name. Okay, so decoder, one second, decoder 2 to 4. Okay, so otherwise project name I'm giving as what, decoder. Project name is decoder, and next day 7 sim. This is the path. Okay, and I want to add the existing files. So here RTL, add decoder 2 to 4. Okay, add the existing file. TB, add decoder 2 to 4 TB. Okay, okay, and close this and select these two. Right click, compile selected. Okay, I got tick marks without any errors. Go to library, go to work function. TB I need to simulate. Okay, TB file I need to simulate. So right click and simulate. So simulation will open. Simulation window will open. So go to, yeah. So after opening the simulation window, in the decoder, right click, add wave. Okay, the waves will be added. DUT also I want to see. If you want to see, add wave. And here you need to group the TB files and as well as DUT files. Okay, so copy this, select this, and group this as TB file. Okay, and next group DUT files. This is DUT. Okay, okay, and next go to run all. Okay, we'll get this waveform. So expand this and zoom full. So here you can see. So see here when decoder in is 0 0. Okay, so which is activating out or 0 is activating. Okay, remaining all are 0 only. When decoder in is 0 1, you are getting 0 0 1 0. So that means in 1 is high, remaining all are low. Okay, decoder in is 1 0. So here out 2 is activating and remaining all are low only. Okay, decoder in is 1 1. So here this out 3 is activating. Okay, so you are getting 1 1 0 0. So 1 0 0 means out 3 is activating, out 3 is high, remaining all are zeros only. Okay, so like this we can see the waveform in the model sim. Okay, yeah, so this is 2 to 4 decoder. Next is we'll see the next we'll see the 3 to 8 decoder. Okay, so this is 3 to 8 decoder. This one I will close this. Yeah, 3 to 8 decoder. So 3 to 8 decoder means it have how many inputs? Three inputs. Okay, and eight outputs. Okay, so module. What is my module name? Module name is 3 to 8 decoder. Input. I'm using a vector 2 down to 0 in. Output range is 1 down to 0 out. Okay, and I'm using an integer data type, integer I. Okay, always at the rate star. This is for what means I need to clear the outputs. Okay, I need to clear these outputs. So for this, what I am doing, so always at the rate star begin. First, I am clearing the outputs of this decoder, output to 0. Okay, and here I am using for loop. Okay, for I equal to 0, I less than 8, I equal to I plus 1 begin. Okay, if I equal to in, then out of I equal to 1 tick binary 1. So that means initially, suppose if I equal to 0, so I is less than 8, the condition is satisfying. So if condition is satisfying, so now what happens, I will be incremented. Next, it is checking for condition. If I equal to in, so that means that is 0th bit equal to, that is in of 0, uh, out of 0 equal to what? 1. Okay. Next phase, what happens? I becomes 1. Okay, 1 is less than 8. The condition is satisfying. Okay, so that means that 1 is allocated to in. That is what in of 1. If in of 1 is 1, out of 1 equal to what? 1. Okay, like that. In of 2 is 1 and out of 2 is 1. Okay, like that. It will make the output till this out of 7. Okay, when it becomes 8 means this condition is not satisfying. It will come out from the loop and end module. Okay, so here I am using for loop for making the inputs and outputs. Okay, and after that, test bench. So module, what is my module name? TB underscore decoder underscore 328. So we need to declare the internal variables of the test bench. So in with 2 down to 0 and wire 7 down to 0 out. Okay. So reg, so in I am declaring with reg data type. Reg 2 down to 0 in and wire 7 down to 0 out. I need to instantiate my design. Okay. How to instantiate? Uh, Design name followed by the instance name. So this is my design name followed by the instance name. What is my instance name? DUT dot in dot out. Okay, these are the variables outside the bracket are design inputs and outputs, and variables inside the bracket are text bench variables. Initial, begin. So these are the two commands I already explained for to execute in the EDA playground. Dollar dump file decoder 328.vcd dollar dump vars 0 comma tb underscore decoder underscore 328. Okay, and I need to give the stimulus. I need to give the test vectors. Okay, so how to give the stimulus in 3 down to 0 0 0 0 every 10 time units. Here I given the time scale, no? So 1 nanoseconds means every 10 nanoseconds I need to change the input and you need to give the stimulus. Okay, so that this input will this variables will be driven to the design will process and that will give to the test bench. Okay, dollar finish is actually for termination of this simulation. We are using a system task dollar finish. Okay, so this is the code and test bench related to the 328 decoder. Okay, so I want to execute in EDA playground. So select the new playground. So go to this. One second. Here, copy this code, and here we need to paste the design and copy the test bench. Here we need to paste the test bench. Okay, and go to simulators, tools and simulator, Aldec Rivera, and open EPP form after run. Okay, save and run. So we got the waveform. So here this is how many bits? 8 bits. And in is how many bits? 3 bits. Okay. So when in is 0, out 0 is 1. Okay. Remaining all are 0 only. Okay. So at a time, any one of the output of the decoder will be high. Remaining all are low only. Okay. So when in is 1, then out 1 will be 1. Okay. When in is 1 0, actually 0 1 0 only. 0 1 0 means out 2 will be, so here out 2 will be high. Okay, here out 2 will be high, like this. Out 2 will be high, and next 1 1 out 3 will be high, and 1 0 0 out 4 will be high. 1 0 1 out 5 will be high. Remaining all are 0 only, and 1 1 1 out 6 will be high, and 1 1 1 so out 7 will be high. Okay, so like this we can get the waveform. So this is in EDA playground. So I want to see in the Vivado. So the close the simulators, discard this. So close this. And you need to go to the design source, add the design source, create the design source. So create the file name, give the module name only. Okay, file name as the same as module name. Copy this. Okay, okay, copy this and paste here. Choose the location, decoder, select, OK, and finish. Okay, module name is also same. So this is 328 decoder. So copy this and paste here. Save. Go to the simulation. Create the simulation source. Here TB file. Copy this. Paste. Choose the location. Decoder. Select. OK. Finish. And module name is also same. So this is my TB file. So here copy this and paste here, save. So you want to see the design in the design source, you need to make as a top module. Similarly, if you want to see the simulation sources, 328 decoder also you need to make as top module. Okay, and so open elaborated design. I want to see the design, how the tool is converting my RTL code into gate level netlist. Okay. Yeah, like this, the tool is converted the code into so gate level netlist. Okay, so here three inputs are there. Outputs how many is 7 down to 0 means eight outputs are there. Okay, run simulation, run behavioral simulation. So you can see in this one, expand this fit to page. Here you can make this as what binary radix binary, and this radix also just to make as binary. Okay, so if you see here 0 0 0, so that means out 0 is 1, 0 0 1, out 1 is 1, 0 1 0, out 2 is 1, 0 1 1, out 3 is 1, 1 0 0, out 4 is 1, 1 0 1, out 5 is 1, 1 1 0, out 6 is 1, 1 1 1, out 7 is 1. Okay, so like this we can see the output in the Vivado. Okay, Xilinx Vivado. Okay, and coming to the quarters prime, so go to file, new, one second, go to file, new project wizard. Okay, next, so same folder only. So I created RTL, SIM and TB. No, so this is my code, same whatever I explained, same code only. So here we need to give this module name, copy this, and here project name is paste. Okay, next, okay, no, next, add the RTL file, RTL, okay, decoder 328, and RTL file is added here. Okay, my RTL file is added here. Decoder 328, next, and select the FPGA family. Next, next, and finish. Yeah. So the RTL file is added. Go to analysis and synthesis, start. Yeah. So I got zero errors. Go to analysis, netlist viewer, netlist in the next viewer, RTL viewer, open. So like this, so the code is converting into RTL, I means gate level netlist. Okay. So like this, three inputs, eight outputs, depending on the input combination. So output will be activated. Any one of the output will be high, remaining output will be low only. Okay. And coming to the model sim, so file, go to new project. I want to close this. Just yeah, quit sim. I want to close this simulation. 1 second. So model sim, file, new project. Yes. So what is my project name? Just to give this. So project name is yeah, decoder 328. Decoder 328. Same. Okay. And add the existing file. So in the RTL, decoder 328, open. Okay. And in the test bench, decoder 328, open. Okay. And close. Okay. Next, select these two, right click, compile selected, and compile selected. Next, go to library. In this decoder 328 TB, you need to simulate. Yeah, we need to simulate. So decoder 328, add wave. Okay. So it will be added. Here it is added. And next, DUT files, add wave has been added. Uh, so here what you need to do, you need to group this. Group. This is TB, and right click, group, and DUT. Okay. Expand this and zoom full. Not zoom full. Run all. Okay. No. Now I got the output in the waveform. So here you see, yeah. So here, if you see, this is in and this is out. Okay. So when in is 0, 0, 0, out 0 is 1. Remaining all are 0 only. Okay. And when so when it in is 0, 0, 1, and out 1 is 1. Okay, 0 1 0, out 2 is 1. Okay, like this we can see here 0 1 1, out 3 is 1, 1 0 0, out 4 is 1, 1 0 1, out 5 is 1, 1 1 0, out 6 is 1, 1 1 1, out 7 is 1. Okay, so like this we can see the output of the 2 to 4 decoder and 3 to 8 decoder in EDA Playground and Xilinx Vivado, okay, and Quartus Prime and Model Sim, okay. So with this we completed the coding part, means this 30 days Verilog session for the combinational circuits, okay. So next from day 8 onwards, I'll start with the sequential circuits. I will start with latches and next we'll go with flip-flops, registers, counters. Okay. So that all I will discuss day wise. Okay. Hope it will be helpful for you. Okay. Thank you.